All right, so just a little bit more review with finding and comparing constant of proportionalities. So the first problem we have here is that a recipe is calling for 3 ounces of flour for every 2 ounces of sugar, and we want to find this constant of proportionality. Now, for this particular type of a problem, probably it's going to be more advantageous to understand it as um, a ratio. So we're going to say that for 3 ounces of flour, we need 2 ounces of sugar. Okay. So we have 3 ounces of flour compared to 2 ounces of sugar. Okay. Now, in this problem, that's all fine and good. Uh, but what this doesn't do is it doesn't tell me how much flour I need for 1 ounce of sugar. So I can find this as a unit rate. This would be my constant of proportionality. And just a reminder that when we're doing constant proportionality, that we're talking about this k value, and k is equal to the y over the x. So as a k value, it's y over x. So I'm going to say that my 3 ounces over 3 ounces of flour over 2 ounces of sugar is just going to be 3 divided by 2. Now 3 divided by 2 is 1.5. So that means we have 1.5 ounces of flour for every 1 ounce of sugar. So the K value here would just be, we could say that K equals 1.5. And that's all we needed to do here is just find that constant of proportionality, right? Now, the second problem that I present is going to have us use a constant of proportionality. So in this problem, they actually give us that we bike 11.2 miles in 1.4 hours. And the key here is that it's at a steady rate, meaning it's not changing. What equation represents the proportional relationship between the x hours you bike and the distance in y in miles that you travel? So again, we need to find this k value, and k value is always y over x, which in this case, they tell us that the miles are the y. So this is miles over hours. And that was just because it was given to us in the problem. That also helps us because we know that the equation's got to be y equals k times x. And so this y is going to be the miles, the k is going to be the hour, or the x is going to be the hours, and the k is the miles per hour that we're about to calculate. So I'm going to write my k value. I'm going to say k is going to equal 11.2 miles over 1.4 hours. So what that does is that creates a division problem. Now, this is just something as simple as typing it in, or you can actually fill it out longhand. But most of the time we're using a calculator. But if you do this, you actually find that this ratio is 8. So it's 8 miles per 1 hour, or we could write this as just 8 miles per hour. Now, we found the k value. Great. But we're not done because they actually want the equation. So what I do is, since I found k, I'm just going to come over to my equation and I'm going to rewrite it, and I'm going to substitute k with 8. And so I'm just going to say y equals 8 times x. And this is the equation that they're looking for. So we can go one more step. And the next step is to kind of get into a deeper process. And this says that the water is steadily dripping from a faucet into a bowl. You want to write an equation that represents the number of millimeters or milliliters, Y, of water in the bowl after X seconds. So a couple of key points here. Remember, our format is Y equals KX. That is the equation. They're telling us that y is going to be milliliters of water. They're telling us that x is going to be seconds. So that's our ultimate goal. We have to find this equation. They want to know what is the constant of proportionality for the relationship between the number of milliliters of water, y, in the bowl in the time x seconds, and then what is the equation. So they give us this table, and they are so nice because they already labeled for us that we have an x value and we have a y value, and we know that k equals the y divided by the x. So we can actually fill this out already. So we can say that this k, if I take this particular portion here, we're going to take 320 and we're going to divide that by 20 because it's 320y divided by 20 seconds. Now, this is just kind of like a rate problem, and this just equals 16 over 1. And we can try it again. We can take 560 and we're going to divide that by 35, right? So 560 divided by 35 is going to yield us a result of 16. So we know that this is also going to be 16, and we have to double check, right? You cannot just assume, all right? I can't tell you how many times I've had to tell my students, please check every single one, right? So 720, and we're going to divide that by 45, and 720 divided by 45 is still going to be 16 over 1. And last but not least, we want to double check and say that 960 divided by 60, right? And that's also going to be 16 over 1. So we have found that there is a constant of proportionality. We guaranteed it by checking all of our work, and we found that the k value, k, equals 16. So that's 16, again, milliliters per second. So what do? Well, I answered the first question. What is the constant of proportionality that they wanted? But then I have to answer the question, what is the equation? So I'm going to come back here, and I'm going to substitute this k with a 16. And so I'm going to rewrite this equation as y equals 16x. And that is my equation. From there, I'm done.